Your old standard differential equation constant discovery. That's all that is. So any questions from homework stuff? Where are you guys at? The homework. Let me say this. Quiz. A week from today, next Wednesday. 4, 3, and 4. 4? Yeah. 4, 3, and 4, 4. There's a couple things to finish up in 4, 4. We need to do a couple example problems. The 4, 4 is a section you can just, I like to say this phrase, but you can sink your teeth into 4, 4. But I mean that is not all touchy-feely. It's just straight up, see the answer, see the thing, assume it looks like this, do the derivatives, plug it in, figure out what the coefficients are. It's very formulaic. It's very, there's a couple things we need to talk about, a couple of special cases that we need to look at, and we should probably do a few more examples. So, no questions from homework? Yes?
You said that 4, 5 is extra credit.
Yes, thank you. To remind everybody, I said I was thinking about it, and then I basically said I'd do it, but just make sure you guys, 4, 5 is extra credit. I will talk about a couple things. Something called an annihilation operator. Sounds like, Bruce Willis is on the phones. The annihilation operator. So, two brothers. No. There you go. So we have one thing out of 4, 5 I want to talk about. The rest of it's extra credit. 4, 5 basically ends up in the same place 4, 4 did. It just does it in a very kind of different way. And one of the ideas, that annihilation thing, does pop up later, so I might as well talk about it. So a couple of things to finish up in 4, 4. Let's just jump right into a problem just to see if you guys get this idea. What did I say? Yeah. So if I ask you to solve this DE, what is the first step?
Finding the when n equals 0.
Yes, right? Find the associated homogeneous to find the complementary solutions. There's a lot of words. I almost don't care if you don't know the words, as long as you know how to find these things, right? The associated, the mass homog, all right? That's the answer, not a few things. This would be y double prime plus 8y prime plus 16y equals 0. I've got to find those solutions, because whatever makes it come out to be 0, I can add it to what makes it come out to be 64 cosine 4x, and it's not going to mess with it, so it'll work. So we've talked about that idea before. Hopefully that makes sense. How do I do this then?
4, 3. Just simple, find the auxiliary then.
Yeah, find the auxiliary equation, in which case it would be m squared.
Plus 8m plus 16.
And never forget why. Remember, we're not going to do the little steps that get me here, because now I'm just so good. But don't forget, we're assuming y is e to the x, m e to the mx, and then when you plug it in, all the e's to the mx stuff cancels because it can't be 0. I mean, there's a whole series of things that leads me between these two, but now I can just kind of go straight between those. Homogeneous DE with constant coefficients. Kabam. Notice we keep saying with constant coefficients, because when you have non-constant coefficients, that's where you start to get infinite series solutions and shit like that. So that's coming up very soon. Yeah. So how do you do this? And when you have repeated roots,
X.
yeah. So what's yc going to be?
C1 e to the negative 4x, then C2x.
Yes. That's how you deal with repeated real roots. I like it. So if it would have been a third power, it would have been plus c3x squared e to the negative 4x, and so forth. And we proved why that's true. Again, so I keep saying that because sometimes students lose contact with why this is true, and then that messes you up later. You've got to keep reminding yourself a little bit about there is a reason this is true. I can go look at it, but just to remember why this is true. All right, enough of that. All right, so that's kind of old news, but that old news, the reason we did that before is so that because it's a part of solving this thing. So I know it makes it 0, so that's not the answer, but I can add it to whatever the answer is, and it's not going to screw with it, right? So what the shit? What do I do with that? I mean, with that answer, that is an easy function, right? And if you look at the list of functions they give you in section 4.4, hopefully somebody out there is reading these sections or at least flipping through it. Page 143, there's a whole bunch of, obviously, polynomials. That's what we did last time. Sine, cosine, exponentials, and all kinds of products of all those. Those are all functions I could do this approach with because they're easy functions. Their derivatives are based on each other and so forth. They work. So what would I assume that the YP looks like? What would it have to? What would it have to look like? What would it have to? Yeah, it'd have to at least cosine 4x, but yeah, I don't know. A clue, it's A, right? Is that it? No. Because what else could it be? Yeah, it could be the same thing except sine, plus b sine 4x. I like it. So if I see a cosine or a sine on this side, then my assumption is going to be the answer is going to look like this. And it pretty much has to, right? Okay. All right, now I want to point something out. Are any of these part of this? No. If they were, that's going to be a special case that we've got to consider. Because if any of those were a part of this, then they actually make the sucker become 0, and that's a problem. They don't make it become what I want it to be. We'd have to figure out what the hell to do with that. Okay. So, if I assume this, how do I do this problem? Well, now I just got to, let me just put a y there. I know this is yp, find yp. So then what's y prime? I mean, now trust me, I'm not going to give you a lot of these on a test or something because they do become kind of long sometimes, depending on how many parts there are. You have to do a few derivatives and you have several parts and all that shit, so it does become a little long, but this is just, it's not hard. It's just you got to have stamina to get through it. So y prime will be
-4 sine 4x 8. 4 cosine 4x.
and y double prime will be 16a cosine 4x minus 16b sine 4x. So obviously, if you screw up a derivative here, you're screwed. It's never going to work, right? So go a little slowly through there. And now if I plug this stuff in, right? Plugging that stuff in, I get negative 16a cosine 4x minus 16b sine 4x plus, well, let's see, plus 8 times this will be minus 32a sine 4x plus 32b cosine 4x plus 16a cosine 4x plus 16b sine 4x, that's nice, equals 64 cosine 4x. Is that cool? This actually, if you let it be, this is one of the easiest things we've done this semester. It's a little long. Second derivatives can get long, especially if the form of this would be like a product. You can imagine that would have the higher derivatives start to get gross and you have to be careful. But it's easy. It's really nice. So, of course, here, these go away. These go away. So I have negative 32a sine 4x plus 32b cosine 4x equals 64 cosine 4x. So what's a got to be? 0, because there ain't no sine 4x's over there. Let's just show off my fine grammar. So a has to be 0. I don't have to do any work there, really. And then b has to be 2. So what's the particular solution then? What's the yp?
2 sine 4x.
Yeah, go back up to your assumption of what the answer looked like. Right? So then you get y equals 2 sine 4x. That's yp. So then what's the, is everybody, let me see, I see a few, yes?
How did you get a equals 0?
Oh, are there any sine 4x's over here? No, so then that a has to be 0. I like it. Yes?
So why isn't YP the 2 cosine theta?
Well, b is 2. And you're actually making a point about that. I was trying to figure out how to say. Don't go off of what you see here. You got to plug it back into where a and b came from, right? Does that make sense? Don't go, well, right here, the b is in front of the code. No. A and b came from this. These are just derivatives to plug in the thing. This would be the answer. I'm glad you kind of did that because a lot of people make the same mistake. Okay. So what would the general solution be? You would just have to do
YC plus Y.
yeah, y equals yc plus yp, so you do this plus that. I like it. Notice how there are no constants here, which the book makes a point of. That's one reason why I like this is yc, it's the one with all the c's in it. Yp is the particular thing that makes all the numbers work. That's why I can't have any c's in it. Okay, I like it. I mean, and this is basically the way any of these problems work. Now I want to show you something. I'm going to leave part of this up here and change one key part. All right, so everybody got this stuff here? Everybody got this stuff here? Okay. Thank you. Clapping in the right sense. What if I made this? Ooh, yeah. So it's a whole new problem now. Whole new problem. This doesn't change though. Is that cool? This only gives a shit about what this is. It kind of ignores that other piece. It's just the associated, it makes that 0. So what's really going to change here is
The y.
yeah. So what form is the answer going to take? Well, that sounds too specific. So with a, e, negative 3x. I want to ask you, if you take derivatives, what is the core functional piece of it going to be? It's got to be this. If you assume it's ae to the negative 4x or ae to the bx, that doesn't make any sense. It's got to be based on e to the negative 3x. I just don't know what the number out front is to make this come out when you do all this shit to it. That's why this is called undetermined coefficients. I know what the functional piece is. I just don't know what the number out front needs to be. You guys understand this? I mean, on one level, this might feel like cheating. The more you start to realize what this is, you say, well, how the hell do you know this? Well, because, think about it. That's the only way in hell this is going to come out of adding a bunch of its own derivatives to itself. I mean, I see some people with questions that they're not asking. Come on, ask it. Yes?
Why, like, could you potentially do it as negative a e?
Totally, of course.
Like,
Yeah.
you don't necessarily
And then if I get 2, you're going to get negative 2, but we're going to end up with the same answer here, right? I love it. Exactly. And you could use a Russian letter. I don't get right. I mean, on that level, it doesn't matter. You can use a over 2, and then your a will be twice as much as mine, but yours is going to get cut in half, and we'll agree at the end again. I love it. That's why you just suck in all the extra shit into the constant.
Will it always be like cosine and sine and e?
Yes, if you look at this list. Now it gets a little bit, now polynomials also, because that's where we started with this stuff. But if you look at the list, page 143, it's polynomials, sines and cosines and e's, and then products of those. So we're still going to do one more problem after this involving the product of those. Once you get the general idea, it's very nice. It's like, oh, you just got to let it be nice. Some of you guys really hate taking derivatives, but I'd rather be doing that than something that just doesn't make any sense. I mean, right?
Is your A -1 in that for that to be true?
No. Well, I don't know yet. Have you already done the work?
Yeah.
Okay.
Sure.
Yes, it is. It didn't have to be. It's not because of anything other than that's just the way this comes out. This could be anything. I don't know yet. But how do I start to do this? Same way I did earlier. I'm going to do y prime. What will y prime be?
-3a 9.
So then I get 9a e negative 3x minus 24a e negative 3x plus 16a e negative 3x equals negative e to negative 3x. So I get basically 25 minus 24, I get a e to the negative 3x equals negative e to the negative 3x, so I get a is negative 1.
All right.
So yp, no, yp would be,
Negative.
oh, it's just for me, I like that.
What would we do with the polynomials? Would it just be like 4, 3?
All right, we'll do a real quick polynomial one. All right, you with me? In fact, we'll do the same. And so, what would the general form of the solution be here?
The same.
Yc plus yp is this plus that, right? Is that cool? I really am trying to make this distinction for you. This thing doesn't give a shit about the function on the other side, because it just makes this thing become 0. That's the whole purpose. This stuff completely cares about what this is. And then when you combine the two, you get an answer for it, because this makes it 0, it gets out of the way of what this makes it do, which is makes it do this. Okay.
In 4.1, I believe there's a couple questions that like gave you like a differential equation, and then they asked what's the associated homogeneous equation. So like that's that right there, right?
Exactly. I like it. So it's just making that piece that the book is called f of x and g of x on occasion, this thing, make it 0. Right? Okay. So to answer the question that was just asked, everybody cool with this? So if I had here instead 2x squared minus 5, I like it. What form will the answer take?
Would it be ax squared plus c for b?
Now you don't really need this here, right?
Yeah.
Do you?
No.
Do you?
Because it's not in the original.
Put a 0.
Now if you put it there and you don't need it there, it's not going to mess anything up. But if you put it there and you don't need it there ever, then that's like extra work that you don't really need to do. So do we need that term there? What do you think?
No.
And then from there, just go down the steps, take derivatives, and go from there.
All right, let's leave the term there for right now. Let's see what happens. So what's y prime?
2x.
Aren't these going to interact? And maybe b is equal to negative 2a? I mean, so already I've just shown you that you need that term there. Because maybe it's there and the derivative makes it go away. Do you guys see what I'm saying? No? No, all right. You're combining second, first, and the original equation, or first, second derivative, first derivative, original equation, with some kind of multipliers. Just because it's 0 here doesn't mean it was 0 at the beginning. Maybe the combinations made it go away. All right, I like it. And well, I'll show that. Did they give you an example like that? Yes. Yeah, well, if you have your book open at page 143, you would not make the mistake. And some of you guys are like, if I had my book here. All right, so what's y double prime? 2a, crazy. So then you get 2a plus 16ax plus 8b. Is this cool? Blah, 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 blah. Plus 16ax squared plus 16bx plus 16c equals 2x squared minus 5. I like it. So therefore, A has to be what? 16a has to be 2. So A has to be 1/8. Let's see what else we got. 2a plus 8b plus 16c. 2a plus 8b plus 16c has to equal -5. I know what A is. A is 1/8. So this would be 1/4 plus 8b plus 16. You can do it, Jeff. That looks gross. What's the other equation I can make? 16a plus 16b has to equal 0. Right? I didn't miss anybody, did I? No. Which means A has to equal -b. Which means B, or better yet there, A is 1/8, so B is -1/8. So now I know 1/4 minus 1 plus 16c equals -5. You can freaking solve for C. I mean,
Why does that have to equal 16a plus 16b?
because are there any x terms there? When I combine the x's with the x's, I'm supposed to get how many x's? 0 x's. So 16a plus 16b, whatever the hell they are, they better equal 0 because there are no x's over here. Good. And again, this is that part of partial fractions that people don't hate as much necessarily. You just hate the whole thing. That part's not that bad. Equating coefficients, right? Is it required? I don't know. What the hell would this thing be? Who cares? 3/4. I don't care, right? You get C equals some number, right? Whatever the hell it is. And then you just plug it in there, and that's your particular solution, plus this will equal your general solution. Is that cool? Do you guys see that? So if I change this side, what's that going to change? It's going to change this. And then, of course, it's not going to change this, but it's going to change, what you end up with here, right? I like it. So this is very, very, what's the good adjective here? Just bedrock. It's not amorphous. If you take it linear to me, a lot of linears. Anybody taking linear here? I think a few of you guys. Would you agree with that? It's a little bit theoretical and abstract, and this is like, you can jackhammer to it, and you work it, and then you get the things popping out, right? Maybe? I don't know. All right. I don't have that much time to be doing that shit. Okay. What was the other thing I wanted to do? Blah, 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 blah. Oh, so last couple things in 4.4, I've desperately got to do a little bit. Oh, here. Here's the special case I was talking about. And this should feel very familiar. Here. Don't write that down. Okay. Plus 4y. Bam. There you go, Jeff. Then it's factored. It's crazy. So what's the associated homogeneous?
Equals 0.
Yeah. So y double prime. What's up, Dan?
What is that? 8e to the x?
8e to the x. Yeah, sorry. That was a little bit funky. So then the auxiliary, I'm just going to kind of go through this a little quick. I mean, this whole thing you guys can do. So you get m minus 4, m minus 1. So you get YC is e to the 4x, C1, C2, e to the x. Is that, you guys can all do that. If you can't, you're in a bad place. This should be like, this whole section should be like, oh, that's awesome. Even if it's freaking complex numbers, it's not that horrible. Speak for yourself. So YP, I'm going to assume what?
A e to the x.
Now that can't be true. Can't be true. Because what does a e to the x make this turn into? 0.
Say it's C2.
Do you see what I'm saying?
Wait, can you say it?
So my YP, it's supposed to be what I put in here to make this pop out, right? That's why I base its form on the form of this. But this is going to make it come out to be 0 because it's basically this. These make it come out to be 0, so that's going to make it come out to be 0. So this should feel very familiar. It's just kind of like when you have repeated roots for the homogeneous. So you have e to the 4, you already have an e to the 4x, so you better make the next one x e to the 4x, so you better make this for very similar reasons. This is going to involve product rule. It's going to have a part that is just e to the x. So whenever you have a form here, the form you're going to guess is already a part of the complementary solution. You've got to multiply it by enough x's until it's not the same. So if I had an e to the x and an x e to the x, I'd have to assume that this is going to be ax squared e to the x. I have to multiply by x's until I'm out of the range of this shit, right? So I only had to multiply by 1x because then now, is that a part of this? No. Do you guys see what I'm saying? So this would have been x e to the x already. That wouldn't be good still. I have to do x squared. If I already had an x squared, I have to do x cubed. I mean, let's just keep on going. All right, and now you can do your y prime, your y double prime, you shove it in there and do all stuff. All right. Same stuff we just did. That's the special case where a YP form is already a part of YC. There's no way in hell, you already know it's not going to work. So why do anything? So the way to take care of it is to multiply by x until it's free and clear of these guys. I love the look on certain faces. It's very similar to why we had to do that before. Let me see. Did I miss anybody else? No. Oh, last thing. Man, rawr. I am gonna fit this in. I don't care. All right. Whatever, John. All right. If I had something like I don't really care, equals. Let's do this. X squared e to the x plus sine 3x minus x. Superposition principle makes this easier than it first seems. Right? You could actually, if you wanted to, you could write blah, blah, equals this, blah, blah, equals this, blah, blah, equals this, solve all three of those, and then just combine your answers. And to be honest, that doesn't make it any more work than just leaving it together. It actually makes it easier to look at.
You're talking about breaking the plus signs into different equations?
Yes,
So-
yes.
Oh.
Because superposition of particular solutions. We've seen that before. There's a problem where it said, solve by observation this, solve by observation this. Well, what's the answer to this, where they combine the two? Well, it's just the combination of the two solutions you just got. That's superposition principle. If I get a YP that makes that happen, and a YP that makes that happen, and a YP that makes that happen, what's the answer to this whole thing? Those things added together. Because each one will contribute its own piece, right? Now, what's the form of this going to be, though? So this is where you do the multiplication rule. This is you would say ax squared plus bx plus c times e to the x. And you can distribute that, whatever. Cool. And again, that's in that table, they have one, yeah, number 9 is almost exactly what I've got there. Yeah. And then what would this one be? So if you wanted to, you can make one big string, and you can say plus d sine 3x plus e cosine 3x, right? Or you could, like I said, do this and equate coefficients with this. Do this, start over at a, treat it like a separate problem. Do you guys start to see? You don't have to put it all. I always hated to see the whole thing all together, even though the math didn't give a shit. I'd rather like to throw it into chunks. So the y for this one would be a sine 3x plus b cosine 3x. And what about for this one? So yp1, yp2, yp3 would be ax plus b.
Why are you having that plus B over there?
Oh, just in case. I mean, it's. Let me think. No, in this case, you're right. In this case, since there is no constants, you don't have to. There's no way that there would have to be a b here. Let me think about it for a second.
Because you're taking just derivatives.
Yeah, since it's all out by itself, I don't think you need this. No, yeah, you do need that, just in case, because again, it's going to interact with the second derivative, or the first derivative in this case. Second derivative, of course, is going to go to 1. But the first derivative would be a, which can mess with that b and make them come out to be 0, like what just happened earlier when we were missing an x term. All right, cool. Dadgummit. What do I got? I got negative seconds left, yes.
So in what case would you have to include the
Oh, always. You always include it. I don't know why I was just going through so fast. I had to stop and think for a second. Was it a special something or no? Because of the fact that they're going to interact with their derivatives. So if that wasn't there, this doesn't have a chance to. Maybe a is negative b, and that's why there's no number there. Yeah. Yeah, I like it. When in doubt, put it in there. Because if it didn't need to be there, the math will make it come out to be 0. Yeah.
If it like x squared e to the x, if that was x to the third, then you just start with the higher order.
Exactly. Whatever the power is, that's where you start. Blah, blah, blah. I like it. So polynomials are easy. And so is everything else, to be honest. Study that table, that 143 table, page 143. And please, dear God, we are going to jump right into freaking 4.6 next time. I'll talk about the annihilation shit later, but 4.6 is stupid important. Anyway, so we'll do that like immediately next time. The quiz will be in a week from today. Okay.
Meaning A related to B.
Yeah, exactly. Yeah, so that last problem, they thought we didn't need a B because there are no X terms. You have to, yeah, exactly. When in doubt, include it.
Do you have a second? I just